Okay, here's a take at the derivatives that are on the Chapter 10 pretest. And I think the first one, number 11, I think you should have a sense of what that general rule is. So go back and check your notes on the shortcut. So you should know the derivatives, negative 6x plus 2. And I like that, you knowing that, just because there are plenty of difficult derivatives out there. And just knowing that what you do to find the instantaneous velocity, which is what we're going for here, also known as the slope of the tangent, same idea. You need to get the derivative and then put this x value in to get that slope of the tangent or the instantaneous rate of change. So on the more difficult ones, I've shown all the work here, expanding it out. The technique, this one we've done pretty well in class, where you just get the common denominator, knowing that ultimately you're going to get these h's to cancel in the numerator and denominator. And then once the h's cancel, you can put 0 in directly into the limit and then just get your derivative function, which I have here. Then we can put negative 4 in and get our value. That's our slope of the tangent or instantaneous velocity. So I'm going to change pages while you're watching here. Let's add another page and get another picture here. Let's make this fast enough it's not annoying. Alright, here's the next one. Here's a derivative, and number 13 looks like it's a radical. This is new, so I want you to introduce an idea that you know how to do this. This is, we're multiplying by its kind of like its conjugate. The idea is that if I have, a plus b, or a minus b, and I multiply by the difference, or the sum, the opposite of those, remember that's the difference of squares, and you get a squared minus b squared. Well, that's particularly good when you're dealing with radicals, because what happens is then they cancel. So this is the result of multiplying this, let's say this is a minus b here, times this a plus b. Well, here's a squared minus b squared, which is basically just cancels the square roots. Okay, I'm going to clear those all off of there just to give you, so you can have a clean look at this, and I'll also load this key as a PDF document. But once you do that, the radicals go away, then you distribute the 2 and the negative, and all you're left with is 2h. That'll cancel with the h in the denominator, and you're in really good shape. Oops, I want to undo that. So I just want to delete a few things off of there, not the whole thing. So that should be a nice clean look to it. Once h is canceled, then you can put 0 in for h in the denominator, as you see. And the final look of the derivative, I've canceled, I put in 0 for h, and I got this step right here. And when you're adding two radicals, you can, if they're the same radical, you can say I have 2 of them. So there's 2 radicals, 2x plus 4 quantity under that radical. Cancel the 2's, and then this is your final derivative circled off to the right. The same goes for this next problem down. I think the number 14 is a kind of a replay of what you saw in number 12 up above. You have, just to take a fraction, the x plus h version minus the x version, you get a common denominator, and then after you distribute and do all that, you're going to be able to cancel the h's and move on nicely. I'll pull this up on a new screen so you can see this whole problem, because it looks like it got cut off in my picture. Okay, here's the bottom of that, and there you have it. So there's the last of that derivative. I don't think there's anything you need to be too concerned about. Once you get the derivative, then you plug in the appropriate x value and get the rate of change, or the slope of the instantaneous rate of change, or the slope of the tangent line that we're looking for. So the key is that number 13 is multiplying in that radical situation by an a minus b radical formula. We're going to multiply by a plus b so that you can get those radicals to cancel in the difference of squares. All right, email with other questions. Enjoy your weekend.